going to look at calculus, or more specifically, how we use it to help us to draw graphs, curve sketching. So far we've seen this thing called the first derivative, and different notations for the first derivative. Y dash, or some people call it Y prime, f dash x, d dx, and then whatever the function is that we're differentiating inside the braces there, or probably the most common one, simply just the y dx. Now remember, when we talk about curve sketching, it measures the slope of the tangent at a particular point. So therefore, if that derivative is positive, we know the curve must be increasing. Because if you look at any of the curves that are going up, if you were to draw a tangent at any point whilst it's increasing, it has to have a positive slope. And consequently, if it's going down, then logically it becomes a negative slope. Which means if it's 0, that's when the curve is not going up, it's not going down, it's just stationary. So we're going to sketch a curve simply by looking at the first derivative, and the first derivative alone. So it's going to be a rough sketch. So if y equals 3x squared minus x cubed, let's find those stationary points where we're going to need the derivative to do that. So polynomials, they're nice and easy to differentiate. 6x minus 3x squared. Now, when you are doing your solutions, don't be lazy. Explain what you are doing. All right, I've just found the first derivative. I'm now going to use that because I know that when stationary points will occur when that derivative is 0. That's why I'm making this equal to 0. So that's what we want to solve. In other words, I want to solve 6x minus 3x squared is equal to 0. And that factorizes nicely. We get x equals 0 or x equals 2. There are two possibilities. But at this stage, they're not points. They're just x values. So I can easily substitute back into the equation of the curve, and we get 0, 0, and 2, 4. Be careful. It's very easy to substitute into the derivative instead of substituting into the actual equation of the curve, and surprise, surprise, you always end up with a y value of 0 if you do that. All right, well, let's look at 0, 0. Remember, all we know is the first derivative. If I draw up a little table of values, but instead of looking at the y values, I want to see what the curve's doing. Look at the derivative. So 0 is the point I'm investigating. I know at that point the derivative is 0. I'm just drawing myself a horizontal line there to remind myself, hey, the tangent would be flat at that point. I need to pick a point on the negative side or the left-hand side, and I need to pick a point on the right-hand side to see what's happening. So I can pick any number I like. The only thing is I can't go past any other stationary point or discontinuities. So on the left-hand side, we're right. We could go as far back as we want. I could substitute in, I don't know, negative 5,432 if I wanted to. I just don't want to. I'm going to use negative 1, much easier to substitute in. Substitute in, I get a value of negative 9. So all right, I know it's going down. Now on the right-hand side, I've got to be careful. I can't go past 2. A number between 0 and 2 that's easy to substitute in. Oh, about positive 1. Positive 1 gives me an answer of positive 3, and we're going up. By looking at my little picture of tangents, we can see what the curve's doing. It's going down. It must come to a turning point and then go back up. So that's what we would call a minimum turning point. It comes down to a minimum and turns. Let's have a look at 2, 4 then. So we'll do the same thing. At 2, well, we know that's our stationary point, horizontal tangent. I've got to pick a point on the left-hand side. Got to pick a point on the right-hand side. Now, on the left-hand side, I wonder which one logically I'm going to pick. I've already worked out one, so I may as well use that one again. Now, on the right-hand side, I can go as far as I like. There's no more stationary points. There's no more points of discontinuity. So I could pick 10,427,632.754 recurring. If I wanted to. I don't want to. I'm going to pick 3. All right, sub 3 in there, and we get negative 9. And we get a picture of what's happening there. So it's going up to a maximum point, turning, coming back down. So that's a maximum turning point. Remember, I'm just saying a rough sketch. We know it goes through 0, 0. We know it goes through 2, 4. There we go. That's a very rough sketch. I haven't worked out the x-intercept, I haven't done, but it gives me an idea of what the curve's doing. All right. That will do us for today.